Okay, we are going to be going over the fire hose, its uses, and different types of what we use here in the fire service. Fire hose is a flexible tube which carries water under pressure from the source of supply to a point of where it is discharged to extinguish fire. How maneuverable the fire hose makes the firefighter is greatly dependent upon his or her skill in using the fire hose. Not only is skill necessary, but safety also falls into play. Fire hose is a very common source of fireground injuries. Our basic uses of hose: we use hose for our fire attack, and we use hose for water supply. Some general features of fire hose: fire hose is generally flexible, watertight, and has a smooth lining and a durable covering. Construction features: fire hose is commonly cut and coupled in sections of 50 or 100 feet. You may also see 25 feet sections for a short fill hose. And it's classified by the size, the inside diameter, and the material used in construction. We have 2.5 inch to 6 inch flexible hard intake hose, which is used primarily to draft water from an open water source. Usually rubber covered, fabric, and wire reinforced, and rubber lined. And it's designed to withstand the partial vacuum created when drafting without collapsing. Now, this is specifically only used for drafting with the vacuum. You cannot put this on a positive water source, such as a hydrant to hook to a truck. We have 4 inch to 6 inch woven jacketed rubber lined intake hose, which is primarily used for connecting to hydrants. You may see 1.5 inch to 5 inch impregnated single jacket, polymer covered, fabric reinforced, polymer lined. Smaller sizes are used for the attack lines, and larger sizes are typically used as supply lines. These are nice hoses because sometimes they may be able to be repacked or stored wet without drying and not have the mold or mildew issues. We have 1.5 inch to 6 inch woven jacketed rubber lined hose, generally 1.5 inch to 3 inch, primarily used for attack hoses. We have 4 inch to 6 inch is primarily used for connecting to hydrants or other water sources. You may see 3/4 inch or 1 inch rubber covered and rubber lined booster hose. The outer jacket construction can be cotton, nylon, rayon, vinyl, or even rubber. Hose couplings are typically constructed of brass, aluminum, or magnesium alloys. The construction techniques: there is drop forged, which is made of brass or other malleable metal, and is the strongest and most expensive. We have extruded, usually aluminum or aluminum alloy, and they're lightweight and high strength. There's cast. It is the weakest. It may be used for occupant use hose, such as a standpipe connection in a large commercial building that already has a section of hose and a nozzle attached to it. With threaded fire hose couplings, the male coupling has the external threads and the female coupling has internal threads. The threaded couplings, there's the shank, which is the point of the attachment of the hose, and is attached to the hose by being placed over the hose exterior and held in place by an expansion ring inside of the hose. Lugs assist in making and loosening the connections. There are several different types, such as the pins, which is not common on newer type of hose, obviously most common on older sections of hose. You have the rocker lugs, which are the most common that you see today, and you might even see recessed or usually on a booster line or some sort of smaller hose. The male couplings have lugs on the shank, and the female couplings have lugs on the swivel. The Higby cut is a special thread design where the beginning of the thread is cut to help the coupling thread and eliminate the cross-threading. You want to line up the Higby cuts in order to find the openings in the threads, and then you should be able to thread it on with ease. Storz couplings, they are sexless couplings, identical in neither male nor female types. They're connected or disconnected with a quarter turn. As you can see, both ends are the same. Storz couplings on large diameter hose must have a locking device on them to comply with NFPA 1963, and there's a picture later that will show that locking device. Quarter turn couplings are two hook-like lugs on each coupling. Lugs are grooved on the underside and extend past a raised ring to open the end of the coupling. The lug of one coupling slips over the ring of the other and couples of the other coupling and rotates clockwise to lock. Non-threaded coupling advantages. The hose can be coupled quickly. There's no risk of cross-threading the connections, and since the couplings are identical, adapters are not needed to connect the coupling. The disadvantages of non-threaded couplings. If a connection is not complete, the hose can be uncoupled violently. Hydrants require an adapter to attach non-threaded couplings. And dirt and debris can be lodged inside the coupling's grooves. When coupling hose, we have the foot tilt method. You want to place one foot behind the male coupling and apply pressure to tilt it upward. Bring the couplings together and turn the swivel completely onto the male end and align the flat sides of the hose in the same plane. The over the hip method, you want to bring the female coupling over your hip and attach the male coupling while holding the hose in place using your hip. The knee press method, stand the male coupling on end and place the female coupling onto the male end and place the knee onto the hose above the female coupling. Keep thigh in vertical plane with coupling and body weight to connections. The two firefighter method, one firefighter stands holding the male coupling with both hands against the upper thigh. This firefighter looks away to prevent trying to help align the couplings. The second firefighter brings the female coupling to the male coupling and completes the connection. When uncoupling hose, the knee press method, which is going to be the easiest of all of them when you're by yourself, you want to stand the male coupling on the end, place the female coupling onto the male, and place the knee onto the hose above the female coupling. Keep your thigh in vertical plane with the coupling and apply body weight to the connection. This will apply the pressure downward to help loosen the connection. The two firefighter stiff arm method. Both firefighters hold each coupling and press forward each other. Keeping their arms stiff and using their weight, they turn each coupling to loosen the connection. Different causes of fire hose damage. We have mechanical, worn places, rips, and abrasions. You want to avoid laying or pulling hose over sharp or rough corners. Prevent vehicles from running over the hose, which actually will separate the outer liner and the inner liner and can rub a hole. Open and close nozzles, valves, and hydrants slowly to prevent the water hammer. Change positions of bends when loading hose. Provide chafing blocks to prevent abrasions. And avoid excessive pump pressures. You want to clear debris from the area of hoses during overhaul operations. And clean hose before reloading to help prevent abrasions from dirt and debris. We have thermal damage. The excessive heat can melt or weaken the fabric coverings and dry the rubber lining. You want to protect from excessive heat whenever possible. Do not leave hose in a heated area after it's dry. Keep woven jacket dry when not in use. Run water through hose that has not been used for some time to keep the liner soft. Do not dry hose on hot pavement. Keep away from vehicle exhaust. Shield from the sun with hose bed covers. Roll dry hose in a straight roll for storage to keep the liner from drying out. Thermal damage from cold can rupture the liner, the inner liner, and break fibers in the hose jacket. Some water should flow through hoses to prevent freezing in extreme cold weather. And immediately drain and roll hose no longer in use. Tighten hose connection to prevent the coupling from leaking and freezing. If the fire hose becomes frozen to an ice-covered surface, it can be removed by melting the ice with steam-generating devices, chopping the hose loose with axes. All cuts must be away from the hose, and leaving the hose in place until the weather warms. Avoid using vehicle exhaust heat from the apparatus because of the heat produced. Wait until thawed before folding the hose. And if the hose can be uncoupled, load the hose onto a flatbed vehicle and take it to a location where it can be thawed out. Organic damage, which is our mold and mildew, causes decay and deterioration of the woven jacket hose. The rubber jacket hose is not subject to mold and mildew. Remove all wet hose from the apparatus and replace with dry hose. Remove, inspect, sweep, and reload hose which has not been unloaded from the apparatus or used for 6 months. Inspect and test hose annually. Ensure cotton or cotton blend hose is dry before storing or loading. Cover hose beds to keep hose dry. And inspect hose storage racks and hose beds. Remove and rotate hose periodically. And ventilate areas where hoses. If mildew is found on the hose, scrub the outer jacket with a very mild soap and bleach solution, rinse well, dry completely, and inspect within a few days for mildew. Chemical contact. Chemicals and petroleum products can damage the outer jacket and rubber lining. If hose has contacted an acid, wash it with a solution of water and baking soda. Avoid laying hose in gutters or where vehicles have parked. Avoid exposing hose to hazardous material spills. Avoid exposing hose to a spill of foam concentrate, which can deteriorate. If the hose has been exposed to chemicals, scrub it with a solution of bicarbonate of soda and water. Test hose for possible damage that may have occurred, and dispose of hose contaminated by hazardous materials. Hose left in a hose bed for a long time can deteriorate and crack at the sharp folds. Hose loads should be removed and replaced every 6 months. When reloading the hose, make sure the folds are not in the previous locations. NFPA requires that hose be inspected and service tested within 90 days before being placed in service for the first time, at least annually. If hose has been in storage for a year, hose should be tested if damage is suspected as well. While inspecting fire hose, you want to check the expansion rings at both ends of the hose for burrs, looseness, or damage. Check the inner lining of the hose at both hose couplings for signs of cracks, age, or defects. Check the outer hose jacket for signs of mechanical damage such as cuts, abrasions, tears, dirt, or stress, heat damage, mold or mildew damage, or chemical damage. While inspecting couplings, check the coupling for chips, burrs, or damage, the shape and out of roundness damage, tightness and proper mounting on hose, function and freedom of movement. Check the female coupling gasket for defects, age, and ability to return to normal shape by pinching the gasket between your thumb and index finger. Our care and maintenance of hose. Hard rubber and rubber jacket hose can be cleaned with water and a mild detergent. Our woven jacket hose, remove dirt and dust by sweeping. Wash with water and a mild detergent. High pressure power washers can cause damage and separate from the line. Use a hose washing machine if available. While drying hose, air dry in a rack or in a hose tower. Commercial hose dryers are also available. And never dry hose on hot pavement or in direct sunlight. While storing hose, the hose should be stored rolled on hose racks in well-ventilated areas. Hose should not be stored in areas with excessive exhaust fumes or sunlight. Cotton jacketed hose should be stored to allow for air circulation around the hose. Roll hose with the male coupling inside the roll. Sexless coupling should be stored to keep dirt from collecting in the ramp. Our care and maintenance of couplings. Avoid dropping or dragging couplings. Do not permit vehicles to run over the hose. Examine couplings when hose is washed and dried. Use soapy water to free swivels, but do not oil them. And use a brush to remove dirt and tar from the threads. Hose appliances. Hose appliances allow water to flow through them. We have ball valves for used in pumper discharges and gated Ys. Open when the handle is in line with the hose. Gate valves are used to control the flow from a hydrant. Uses a baffle moved by a handle and a screw arrangement. Butterfly valves are typically used on large pumper intakes. Uses a flat baffle operated by a quarter turn handle. Clapper valves are used in Siamese appliances and fire department sprinkler system connections. It allows water to flow only one direction and prevent water from flowing from unused ports. Gated Y appliances. It divides one hose into two or more with ball valves to control the flow. The most common are 2.5-inch inlets to two 1.5-inch outlets. Siamese appliances are used to combine two or more hoses into one hose line or appliance. Will have two or more female connections coming in and a male discharge exiting. Will have clapper valves to allow one hose to be attached without water flowing from the open connections. Water thief appliances, a variation of a gated Y appliance. The most common water thief has one 2.5-inch inlet with one 2.5-inch and two 1.5-inch outlets. Large volume water thief appliances have an LDH inlet and outlet with two or more 2.5-inch outlets. A common wildland water thief has one 1.5-inch inlet with 1.5-inch outlet and one 1-inch outlet. Hydrant valves allow a supply line to be connected to a hydrant and charged. Additional hose lines can be laid to the hydrant, a supply pumper connected to the hydrant, and pressure boosted without interrupting the flow to the first supply line. So basically you're going to hook up your supply line to the first pumper directly to the hydrant and place some sort of valve on the other side of the hydrant and charge the hydrant. That way the second truck can hook to that appliance without shutting down the hydrant first. Or large diameter hose appliances, an operation may require that water be distributed at various points along a supply line. An LDH manifold appliance can be used to supply other lines from the main supply line. It could also be referred to as portable hydrants, phantom pumpers, or large diameter distributors. We have adapters, are used to connect hose couplings with the same size inside diameter and similar threads. Double females are used to connect two male couplings together. The double male is used to connect two female couplings together. And we have Storz couplings to be threaded to threaded hydrant outlet. Reducers are used to reduce an outlet to a smaller size. It allows a smaller hose to be connected to a larger line. Elbows change the water flow direction. The hose caps will close off male couplings. Hose plugs to close off the female couplings. Suction hose strainers are attached to hard suction hose to prevent debris from entering the pump. Low-level strainers are used with portable water dump tanks. It allows the water to be drafted from the tank when near the bottom. Hose tools, into which water does not flow through. A hose roller, used to prevent damage to hose when being dragged over roof edges or windowsills. It can also be used to protect rope from similar edges. Hose jackets are used to place over a hose rupture or leaking couplings. Consist of a hinged two-piece metal cylinder with a rubber lining. Leather hose jackets wrap around the hose leak and buckled. The hose clamp, used to stop the flow of water in a hose line to prevent charging hose in the hose bed during hose laying operations. Replacement of a burst section of hose. Extend a hose line without shutting down the water supply. Allow advancement of a charge line. A few different types of hose clamps. We have the press-down hose clamp, which is going to be the most common that you will see in the fire service today. There's also the screw-down type and the hydraulic press. When applying a hose clamp, apply at least 20 feet behind the apparatus. Apply about 5 feet from the coupling on the incoming water side. Center the hose evenly in the clamp jaws to avoid pinching the hose. Close and open the clamp slowly. Stand to one side when using a press-down clamp in case the handle suddenly snaps open. This can be very hard to do, and if it will come unclamped, it will come up very violently and you can get hit by it. Spanner wrenches are used to tighten and loosen couplings, as a wedge for prying, opening that fits gas utility valves, and a flat surface for hammering. Hydrant wrenches are used to remove caps from hydrants and open hydrant valves, equipped with a pentagonal opening to fit most hydrant operating nuts. May have a spanner to make or break connections as well. Hose bridges or ramps are used to prevent hose damage from vehicles crossing it, and can be also used as chafing blocks. Chafing blocks are used to protect hose where it is subject to rubbing from vibrations. A hose roll can be also placed under hose as a chafing block as well. Hose straps, hose rope, or hose chains aid in carrying and handling charged hose lines. It gives a secure means to handle pressurized lines, and can be used to secure ladders to fixed objects as well. The method for selecting rolling fire hose depends on whether it is used for storage, but couplings must always be protected from damage. A straight roll is the simplest of all rolls, used for storage, loading hose on the apparatus, or carrying hose to quarters for washing. The straight roll is started by rolling the hose at the male end to protect the threads, and roll hose from male end to female end. Lay out the hose straight and lay flat on a clean surface. Roll the male coupling over onto the hose to start, and continue rolling the coupling over onto the hose to form an even roll. Lay the completed roll on the ground and tamp any coils down into the roll with a foot. The donut roll is for situations when the hose is going to be deployed from the roll for use. Both ends are available and can be quickly unrolled. The hose is less likely to spiral when unrolled as well. Lay the hose in a straight line. Start the roll about 5 feet off the center, closer to the male coupling. Roll toward the female end, leaving sufficient space at the center loop to insert a hand for carrying. Extend the short length of the hose at the female end over the male threads to protect them. The couplings should be within about 12 inches of each other. We have the twin donut roll. It is a compact roll transportable for special applications such as high-rise situations. Both couplings ends are available for unrolling. Place the male and female couplings together and lay the hose flat, forming 2 parallel lines. Fold the loop end over and on the 2 lines. Roll both lines simultaneously to the couplings. With the self-locking twin donut roll, the same features as the twin donut, but the hose is secured together using a portion of the hose itself. We use for high-rise packs, usually several lengths of 1.5 inch or 1 3/4 inch hose, plus selected hose tools and appliances. Hose bed terminology. The front is toward the front of the apparatus, and the rear is toward the rear of the apparatus. It may be divided or hold 2 or more separate hose. A Dutchman is a short fold or reverse bend in a hose load. It changes the direction of the hose and the location of the coupling. Hose loading guidelines. Check gaskets and swivel before connecting a coupling. Keep flat sides in same plane. Lug position is not important. Hand tighten couplings. Do not use spanners. Remove kinks and twist when forming a loop in the hose bed. Use a Dutchman where necessary, so the couplings are not too close to the front or rear of the hose bed, so the hose will not flip over when pulled. Do not pack hose too tightly. This puts excess pressure on the hose itself and can cause the coupling to snag when pulled. It should be loose enough to place a gloved hand between the folds. You want to load large diameter hose with the couplings near the hose bed front to save space and allow the hose to lie flat. A flat load is the easiest to load and suitable for any size hose. Hose is less subject to wear by vibration, and the hose folds have sharp bends, so the hose should be reloaded periodically to change bend locations and prevent lining damage. You want to lay the first length of hose flat along the side of the hose bed or partition. Fold the hose back on itself at the front and lay it back to the rear on top of the first length. Fold the hose at the rear. Lay the next length back to the front, angling it to the side of the first length for the next length. Continue placing the hose in the same manner across the bed, and start the second layer in the same method. The accordion load is an easy load in advance. Hose sets on the edge. Place bends at each end of the hose bed. All flakes are about the same length. You want to lay the first section of hose in the bed on the edge against the bed side. Fold the hose at the front of the bed and back on itself, and lay the hose back to the rear next to the first length. Continue laying lengths of hose to the front and the rear. Stagger the bends at the rear edge about 2 inches between the folds first. First fold of second tier directly over the last fold of the first tier. Continue the second tier in the same manner as the first. The horseshoe load has fewer bends than the accordion or flat loads. Hose is loaded on edge around the perimeter of the hose bed in a U shape. Each length is laid from the outside toward the inside. And when laid, hose typically comes out in a wavy or snake-like lay on the ground. Place the female coupling in a front corner of the hose bed. Lay the first length along the bed wall. Make the first fold even with the rear of the bed. And bring the hose back to the front of the bed along the first length and place it along the outer perimeter of the bed to the opposite side. Make a fold at the end and lay the next length along the perimeter inside of the first length. Continue placing additional lengths along the inside of the preceding lengths. A combination split load used with split hose beds and allows for a forward lay from the water source to the fire and reverse lay back to the water source. The hose on one side of the hose bed is loaded with exposed. The second side of the hose bed is loaded with the male coupling exposed. A double female adapter is used to connect the two beds together. It can be flat, accordion, or a horseshoe load. Another version can be with LDH supply hose on one side and a smaller tack line on the other side. The LDH can be used for the pumper to lay its own supply line. The smaller diameter hose can be used for a supply line when less water supply is needed. Hose load finishes are loaded to provide enough hose for a hydrant connection or a working line at the seam. Finishes for forward lays or straight lay are not as elaborate as finishes for reverse lays. Reverse lay finishes are designed to provide hose at the seam for straight lay finish. Last length or two flaked loosely on top of the hose bed. Usually used as a supply line in forward lay operations from the hydrant. Hydrant wrench and gate valve should be strapped to the hose near the female coupling. A reverse horseshoe load finish, similar to the horseshoe load except the bottom of the U portion of the horseshoe is at the rear of the hose bed. Usually made of one or two 100-foot lengths of 2.5 inch or 3 inch hose with a Y connecting to 1.5 inch or 1 3/4 inch attack lines with nozzles attached. A large loop is at the rear of hose bed to aid in the advancement. A skid load finish consists of folding the last 3 lengths of 2.5 inch or 3 inch hose into a compact bundle on the top of the hose load. 3 or more pull loops are extended beyond the end of the hose bed. The rest of the hose with the nozzle attached is accordion folded across the loop across the pull loop hose. The hose pull loops can be pulled from the hose bed, dropping the entire skid on the ground and then the nozzle pulled toward the fire. Pre-connected hose loads are primary attack lines for fire attack, connected to a pump discharge and a nozzle pre-connected for quick deployment. Can be carried on apparatus in longitudinal beds, divided hose beds with supply lines on one side and pre-connected lines on the other. Raised trays, transverse beds referred to as crosslays, tailboard compartments, side compartments or bins, front bumper wells, or reels. Pre-connected flat load is similar to the flat load for the supply lines, often used as a crosslay. Loops are placed at regular intervals within the load for pulling from the bed. Loading a pre-connected flat load, attach the female coupling to the discharge outlet, lay the first length of hose flat in the bed against the sidewall, angle the hose to lay the next fold adjacent to the first fold and continue building the first tier. Make a fold that extend about 8 inches beyond the bed at a point about 1/3 the total length of the load. It serves as your pull handle. Continue laying the hose, building each tier across the bed, and make a fold that extends about 14 inches beyond the load at a point about 2/3 the total length of the bed for a pull handle. A triple layer load, or the triple flat, the hose is folded in 3 layers outside of the bed. The 3 folds are placed in a bed in an S-shaped fashion. It is designed to be pulled by one firefighter. The entire load must be pulled from the bed before use. You want to start the load with sections of hose connected and the nozzle attached. Connect the female coupling to the discharge, and extend the hose in a straight line from the hose compartment. Pick up the hose at a point 2/3 of the distance from the apparatus. Carry this hose to the truck. Using several firefighters, pick up the entire length of the 3 layers and begin laying the hose into the bed by folding over the 3 layers into the hose bed. Fold the layers over the front of the bed, and continue to lay the hose into the bed in an S-shaped configuration until the length is loaded. The Minuteman load is designed to be pulled in advance by one person. The load is carried on the shoulder and plays off of the top. It can be awkward with wearing an SCBA. If the load is a single stack, it may collapse on the shoulder if not held tightly. Booster hose reels are rubber-covered hose that carry pre-connected and coiled on reels. Booster lines have a maximum output of 40 GPM. Should never be used for an interior fire attack. Should only be used for low-intensity fires and mop-up. Supply hose lays. Hose lay procedures vary with department and in local conditions. Hose may be laid forward from a water source to the incident scene. Hose may be laid reverse from the incident scene to the water source. And hose beds may be split so hose can be laid to or from the incident scene to the water source. Firefighters must remain seated whenever the apparatus is moving. When laying hose, the apparatus should travel no faster than 5 to 10 miles per hour to allow the coupling to clear the tailboard as the hose leaves the hose bed. Hose should be laid to one side of the roadway, but not in the gutter. The forward lay. The hose is laid from the water source to the fire, often used when hydrants are available and the pumper must be at the scene. For forward lays, the first coupling to come off should be the female end. The advantages of a forward lay: the apparatus is at the scene, so its hose, tools, and equipment are available. The pump operator has visual contact with the suppression operator. The disadvantages: one member of the crew is temporarily unavailable by staying at the hydrant to connect the hose and open up the hydrant. A second may be needed to boost the flow pressure if a long lay of 2.5 inch or 3 inch hose is necessary or the hydrant has inadequate pressure. A four-way hydrant valve allows for the forward lay supply line to be charged and another pumper connect to the hydrant. The second pumper can supply additional lines or boost the pressure to the original line. Some departments pre-connect the hydrant valve to the end of the supply line in the hose bed. The pumper stops at the hydrant and the firefighter dismounts and goes to the tailboard of the apparatus. Enough hose is grabbed to reach the hydrant. The firefighter steps off the tailboard with the hose, and the hose is looped around the hydrant and the driver is signaled to proceed to the scene. The cap is removed from the hydrant and a hydrant wrench placed on the operating nut. When enough hose has played from the apparatus hose bed, the hose is unwrapped. The hose is connected to the open outlet. A hydrant valve may also be used. When signaled, the hydrant is fully open. For reverse lay, the hose is laid from the fire to the water source. Allows the pumper to go to the fire and then lay a supply line to a water source for drafting operations or to boost the hydrant pressure. Hose is loaded so the male coupling comes off of the bed first. This is used when setting up relay pumping operations. The biggest disadvantage is that all the needed fire equipment and attack hose must be unloaded at the scene before the pumper proceeds to the water source. Attack pumper and supply pumper operations. The first arriving pumper goes directly to the scene to start the initial attack using water from its own tank. The second pumper lays hose from the attack pumper to the water source and relays water to the attack pumper at the scene. Reverse lay procedures. Sufficient hose is pulled to reach the intake valve on the attack pumper. The hose is anchored under the wheel on the attack pumper as the supply pumper proceeds to the water supply. A hose clamp is applied to the hose at the attack pumper. The hose is then connected to the attack pumper intake. After the supply pumper stops at the water source, an intake hose is connected to the source. The remaining length of the last section of hose laid is pulled from the hose bed and connected to a discharge on the supply pumper. Making a hydrant connection with hard intake hose. Firefighters may have to Assist pump operators and make a hydrant connection following reverse lay. Hard intake hose, which is marked for vacuum use only, should not be used for hydrant connections, as stated earlier. The first point in making these connections is the pumper must be positioned properly for the length of the hose to be used. By dividing a hose bed into 2 or more sections, multiple lines can be laid. If a split hose bed is set up for forward or reverse lays, hose may be laid in the following: 2 lines in forward lay, 2 lines in reverse lay, forward lay followed by a reverse lay followed by a forward lay, and 2 lines laid forward followed by 1 or more in a reverse lay. The method to pull pre-connected hose lines varies with the type of hose load. Advance the pre-connected flat hose load. One arm is placed through the longer loop, the shorter is grasped with the same hand, the nozzle is grasped with the other hand. The load is pulled from the hose bed using the loops. The firefighter walks toward the fire until the hose is advancing the triple layer hose load. The nozzle and fold of the first tier is placed over the shoulder. The firefighter walks away from the apparatus, pulling the hose completely out of the bed. The folded end is dropped when the hose has cleared the bed. The nozzle is then advanced until the line has fully extended. Handling 2.5 or 3-inch hose that is not pre-connected. The shoulder carry, for dry lines, you want to face the hose bed, grasp the nozzle or coupling, use both hands to grasp the number of folds to the hose needed to make up a portion of the shoulder load. And pull the folds about 1/3 out. Turn and pivot into the folds, placing them on the shoulder. Make sure the hose is flat on the shoulder and place the nozzle or coupling in front and hold the bundle tightly. Step away from the apparatus, pulling the shoulder out. Draining hose. The single section drain and carry performs 2 tasks at once. Water drains as the hose is picked up, and the hose should be in a straight line, no bends before starting. Pick up one end and allow water to flow forward. Place the coupling in front of body with hose looped over the shoulder. Walk down the hose, placing loops on your shoulder. Hose lines are easier to deploy before being charged because water adds weight and pressure, which stiffens the hose. However, it is unsafe for firefighters to enter burning buildings with uncharged lines. Fire personnel must be able to work with both charged and uncharged lines. Advancing a charged hose line with a working line drag. It's a quick and easy way to move hose. Stand next to the hose at the coupling or nozzle facing the direction of travel. Place the hose over the shoulder with the coupling or nozzle in front, and hold the coupling or nozzle and pull with the shoulder. Position other firefighters at each coupling to assist in advancing the hose. Advancing a hose into a structure. All firefighters should be on the same side of the hose at all times. The firefighter on the line just behind the nozzle operator should be close enough to help relieve hose pressure from the operator. Other firefighters on the line should be spaced apart to help maneuver the hose line. Feel the door for heat before opening, and bleed air from the hose before entering as well. Set the nozzle pattern for your desired configuration. and stay low and out of the doorway when opening the door. Block doors open to prevent the hose from being pinched by. Advancing an uncharged hose up a stairway. It is best to advance the hose upstairs before it is charged. The shoulder carry can be used because the hose can be fed out as the stairs are climbed. Position personnel about 15 feet apart and facing the nozzle for shouldering the line. Firefighters place hose bundles on their shoulders to advance. After the shoulder loads have been played out, the last firefighters on the line should position themselves along the stairs to help feed the hose. The hose line should be advanced up the stairs against the outside wall for avoiding sharp bends and kinks. Excess hose should be flaked up the stairs to the floor above the fire to make advancing the fire floor easy. Advancing a charged line up a stairway. Advancing the line using the working line drag. Position the firefighters along the route to help feed the hose and keep it on the outside of the staircase. Advance up the stairs against the outside wall, maintaining spacing between. Make a large loop of the hose on the floor above the fire floor for excessive line before advancement. Advance the hose down the stairs to the fire floor using the working line drag. Advancing the uncharged hose line down a stairway. Position personnel about 25 feet apart, facing the nozzle for shouldering the line. Firefighters place hose bundles on their shoulders to advance. After their shoulder loads have been played out, the last firefighters on the line should position themselves along the stairs to help feed the hose. The hose line should be advanced down the stairs against the outside wall to avoid sharp. Advancing a charged hose line down a stairway. Advance the line using the working line drag. Position firefighters along the route to help feed the hose and keep it on the outside of the staircase. Advance down the stairs against the outside wall, maintaining spacing between personnel. Advancing a hose from a standpipe. Many fire departments prepare high-rise packs or high-rise hose bundles to be carried up to the fire floors. Normally, the hose is connected to a standpipe one floor below the fire door floor. The standpipe connection is usually in or near the stairwell. If in an enclosed stairwell, the hose may be hooked to the standpipe on the fire floor. The standpipe connection, remove the outlet cap and check for foreign objects in the discharge. Connect the hose to the standpipe outlet. If 1.5 or 1 3/4 inch hose is used, a gated Y should be placed on the standpipe outlet. Any extra hose should be flaked up the stairs. An improvised standpipe. An improvised standpipe can be used to supply hose lines to the upper levels of an older building without a standpipe connection. The interior stairway stretch is labor-intensive and only used in stairwells with an open shaft or stairwell in the center. An uncharged hose line is suspended in the middle of the stairs instead of laying it on the stairs. Hose rolls are carried up the stairs, secured to handrails, and the end lowered to where another section is attached. The hose is secured to handrails for support at intervals. Advancing an uncharged hose up a ladder. Position firefighters about 10 feet apart on the same side of the line facing the nozzle. The lead firefighter drapes the nozzle over the shoulder from the front on the side which the hose is being carried. The other firefighters drape the hose over their shoulder on the same side. Firefighters climb the ladder, limiting one firefighter per advancing a charged hose up a ladder. Position the firefighters on the ladder within reach of each other, with each secured to the ladder. Each firefighter must be secured with a leg lock. Firefighters on the ground extend the charge hose line up to the firefighter lowest on the ladder. The hose is then pushed from firefighter to firefighter. Operating a hose line from a ladder. The hose is secured to the ladder with the hose strap several rungs below where the nozzle operator is standing. All personnel on the ladder must be secured to the ladder, and the firefighter at the nozzle projects it through the ladder and secured it to the ladder with the strap. The nozzle should be opened only after all personnel are secured to the Firefighters must be proficient in operating hose lines safely and effectively. The one firefighter method for operating small hand lines. Firefighters should never be assigned to operate a hose line alone except during overhaul or a small nuisance fire. The one firefighter is operating a small hose line. Hose line should be straight behind the nozzle for at least 10 feet. The firefighter should hold the nozzle with one hand and the hose with the other. When standing, the hose is cradled against the inside of the closest leg or hold it against the hip. A foot is placed on the hose to anchor it in place. The two firefighter method. A minimum of 2 firefighters should be on an attack line in an interior attack. The firefighter at the nozzle holds it with one hand and the other hand on the hose behind the nozzle. The backup firefighter stands on the same side of the hose, about 3 feet behind the nozzle operator. The second firefighter holds the hose with both hands and rests it against the hip or braces it. The backup firefighter should keep both hands on the hose and not place a hand on the back or shoulder of the nozzle operator. The backup firefighter's job is to keep the hose straight and take some of the pressure off of the nozzle operator. Operating 2.5 inch or larger fire streams. The one firefighter unaided with high pressure loop. A loop is formed with the hose behind the nozzle. The loop is crossed over the line about 2 feet behind the nozzle. The firefighter sits where the loop crosses and directs the fire stream. Two firefighter method, grounding. The nozzle operator holds the nozzle and rests the line against the waist or across the hip. The backup firefighter holds the hose with both hands and places one knee on the hose about 3 feet behind the nozzle. Using hose rope tools with 2 firefighters, the nozzle operator places a rope hose tool just behind the nozzle and places a large loop behind the back and over the outside shoulder. The rope hose tool is wrapped on the line behind the nozzle operator. The backup firefighter also uses a rope hose tool about 3 feet behind the nozzle operator. The 3 firefighter method. The nozzle operator is in the same position as the 2 firefighter method. Some departments prefer the first backup firefighter directly behind the nozzle operator to relieve some of the back pressure. The third firefighter kneels on the hose behind the second firefighter. When extending a hose line, bring an additional section of hose to the nozzle. Apply a hose clamp correctly at approximately 5 feet behind the nozzle and open nozzle. Remove the nozzle and attach the new line. Stretch the line out and reattach the nozzle, and slowly release the hose clamp. Replacing a burst section, use 2 sections to replace 1 section because hose lines stretch under pressure. Apply a hose clamp approximately 5 feet behind the coupling of damaged section. Remove the burst section. Replace 1 defective section with 2 lengths. Flake the hose out and avoid kinks. And slowly release the hose clamp. Keep in mind that this can come open very violently. Retrieving a loose hose line can be very dangerous because of the whipping of the pressurized hose line. It may be necessary to control the line before it can be shut down. The firefighter must be in full protective gear with the face shield lowered. The firefighter then kneels onto the hose about 30 to 40 feet from the uncontrolled end of the line. Moving cautiously, the firefighter crawls toward the uncontrolled end. The end is pinned to the ground to control the line until it can be shut down. Close the valve at the pumper or use a hose clamp at a stationary point on the line. You can kink the hose away from the brake and form a loop in the line by bending the line over itself. Apply body weight to the bend to kink the hose and stop the flow of water. Fire service hose testing, acceptance testing, or proof testing. It's pre-service tests performed by the factory or after delivery to assure it meets its specifications. It's done at pressures higher than anticipated in the field. It should be performed at least annually and should be tested if hose has been damaged before placed back in. Pressurized hose during testing is potentially dangerous. In April of 2000, a Georgia fire chief died from head injuries when a coupling separated from a hose jacket during hose service testing. All personnel operating in the area of the hose testing should wear at least a helmet and be at least 15 feet away from the pressurized hose. The site for hose testing should be large enough to lay out straight runs of the hose, smooth and free of dirt and debris, near a water source for filling the hose. For testing equipment, a hose testing machine or a pumper, preferably a hose testing machine. Hose test gate valve. A hose test gate valve with a 1/4 inch hole in the gate which permits the hose to be pressurized but not surge if the hose should fail. Hose test records. Tags or means to identify failed sections. Nozzles with shutoff valves and marking equipment. You want to keep a written record of the test and visually inspect the hose for all damage and all gaskets before testing. Mark the hose behind the couplings to determine if any movement from the hose under pressure at the couplings. All hose lays for testing should be no longer than 300 feet. Each lay must have a nozzle on the end. Pressure is slowly raised as the lines are filled and the air bled from each line. The pressure is reduced and the line shut down to check for leaks and the couplings are tightened. The pressure is again increased for the test. Hose should be tested to the testing pressure recommended by the manufacturer, which is normally printed on the hose. A tag fire hose is to be tested to a minimum of 300 psi or a pressure not to exceed the service test pressure marked on the hose. Supply fire hose is to be tested at a minimum of 200 psi or a pressure not to exceed the fire service test pressure marked on the hose. The recommended pressure is held on the hose for 3 minutes. After the allotted time, the pressure is slowly decreased and the lines are emptied. All hoses should be then checked for slipped couplings. All defective hoses must be marked for repair. Firefighters must be familiar with the construction and various uses of fire hose and properly care and maintain it. Handling safely fire hose is important to a firefighter's basic responsibility of controlling and extinguishing fires. Improperly used, fire hose can be dangerous to both fire personnel and the public and damage property beyond what the fire has done. And that is the fire hose section. Thank you very much for your time.